So good morning, everyone. Welcome to this webinar on developing novel end products from grass fibers. My name is Jan de Best. And now I hear an echo. So my name is Jan de Best. I'm a professor of biobased resources and energy at Avans University at the Center of Expertise Biobased Economy. And I'm one of the partners in the Grassification project, which is an Interreg 2Cs project. And the Grassification project looks at the valorization of grass from roadsides. And we both look at the reuse of the fibers, and we also look at the reuse of the juice from the grass. Today we will focus on the reuse of fibers. And if you're interested, we're also organizing a webinar on the 6th of July, which will focus on the liquids of the grass and the reuse of that. So about today, I'm happy that still so many people are joining, even though the weather is very nice outside. So maybe you prefer to sit outside, but I think we have quite an interesting program for today, which you can see on the screen right now. I would like to mention that this session is recorded, so if you don't want to be on view, or then please turn off your camera. Well, for today's program, you can see the speaker over here. I will each introduce them separately, and in between I also have some polls for you to ask your opinion about the different aspects of reuse of fibers. With the speakers, if you have a question, you could either raise your hands, and then at the end I will get back to you if you have raised your hands, or you could type your question in the chat. So don't hesitate to ask any questions to the speakers. And then I would like to start by introducing the first speaker of today, which is Nathalie de Vriend from ProNatura. And Nathalie gained her first work experience in biomass as an engineer at Seger Solids and Air in Willebroek, a manufacturer of bioenergy installations. And after that, from 2002 to 2016, she worked as a researcher and later as a project manager on biomass as Vito. And since 2018, Nathalie has been working at ProNatura to look for innovative solutions for the green waste that is released during landscaping and maintenance. Well, she graduated in 2001 as a master in bioscience engineering at the KU Leuven, and today she's going to tell a bit more about the impact of end-of-waste criteria on possible applications of grass fibers. So welcome, Nathalie, and the floor is yours.
Thank you, Jappe, for the nice introduction. I will tell you today a bit more about end-of-waste criteria for grass fibers. I will share my screen with you. Okay, I hope you see the screen. Okay. Yes. I will tell you a little bit about how we at ProNatura make our grass fibers and what the possible end products are, so that you know from where we start and where we go to. Then I will tell you a bit more, what are these end-of-waste criteria, where is it coming from, why do we need it, and then how we went into the procedure during the Grassification project for the grass fibers, and how it ended. So where do we use the grass fibers that we produce, or where not we, but our partners? So you will hear Hannah speaking about their product. So a picture is here, but we have also startups using it for mycelium material, etc., etc. So The screen is doing very strange things here, sorry. So that's where we use it for, and what we are doing, what is the process. So 4 steps, very simple but necessary steps. First, pressing it with a screw press. You see a picture here. That's from a test that we did in 2019. On Friday, we will do another test in Drongen with another screw press where we take out the liquid fraction out of the very fresh grass so that we have a press cake that is less moisture, so that the drying process, what is the second step in the process, doesn't take so much energy. We started up from very small with a sun dryer, as you can see here. We are now in the phase of drying it in a greenhouse, but we are thinking about how to do it full scale, and so we are planning a test at a full-scale facility at the Biomassaplein in Limburg. And we also already visited Van Hede, and they are doing it in a container with a double floor, and where they use the waste heat for drying it. So this is the drying process, and then the end is the milling, where we put in a hammer mill the fibers to have it very small and to end up with a more standardized fiber. And at the end, it's still testing, is it sieving? But just very short, I don't want to go into the technical details, but that you know what is happening with the fresh grass before we have the grass fiber. And where then is the question, the end of waste criteria. What is it? Why do we need it? So where is it coming from? It's coming from a European law or European directive, the Waste Frame Directive. And they have different principles how to manage waste. It's a hierarchy, a waste hierarchy, and they want to prevent that it's endangering the health, environment, water, air, all very noble things, and good that they take care of that, but that has an influence on the end of waste criteria. And it's also in that directive, Europe also describes and defines what is waste that can be transitioned to a secondary raw material, and what is a byproduct. Those definitions are very important before you can start using a certain product or byproduct or waste product as a resource. So these definitions are very important and are the framework where the local regions, member states needs to apply with. So that's very important. In that waste frame directive, there are also very special end of waste criteria. Article 6, 1 and 2, paragraph 1 and 2. I don't go into detail there, but here you see the 4 conditions that they ask for. And if you read those well, you will see that it comes back in the procedure afterwards that we went through at OVAM. So you need to use your waste that you want an end of waste criteria, so that you want to convert in a product. It needs to be used for specific purposes. You need to prove that there is an existing market or a demand for the substance or the object, that the use is lawful, and that the use will not lead to overall adverse environmental or human health impacts. It's very logical and it makes sense, but you will see if you want to apply for it with an innovative fiber, it's not so easy. So that's why I want to stress here 4 very logical things that Europe is asking, but in practice you need to take care of that, and it's not so straightforward. What is then happening? So Europe has the Waste Frame Directive with the end of waste criteria, and then every member state needs to translate into his own end of waste criteria and his own national laws. In Flanders, this is done by the material decree, and there part of it is the grondstofverklaring. Europe has very specific conditions, and I mean very quantitative restrictions for metal scrap, copper scrap, and glass. For all the rest of the waste streams that can become resources, they are more like vague, or they ask to describe. But for these three, there are really numbers that you need to fulfill. For Flanders, when they translated the end of waste criteria to the Belgian or the Flemish law, they added, with the metal copper and the glass scrap, they also had for soil improvement products, building material, landfill, closing material, and ferro and non-ferro materials. Why do I mention it here? Those quantitative restrictions are now in the VLAREMA. If you have other kind of waste streams that not belong to this list, you need to think about your own quantitative restrictions. And that's also a challenge that we met during the procedure. But for these products, you have the really quantitative restriction, or from the European framework, or VLAREMA added it to that end of waste criteria. So that's the framework, the legal framework where all these things fit in. So why do we need those end of waste criteria also for our grass fibers? Roadside cuttings, the legal status here is waste in Flanders. So if you transport it, if you process or pre-treat it, you are a waste transporter or a waste treatment facility. So you need to fulfill certain legal issues, special recognition, administration, permits, paperwork, etc. And that comes with some registration is you need to pay for it. Some investments are needed because you need to do it like this or that or that. Also for a pre-treat and waste treatment facility, you need a permission, a permit, an environmental permit. So everything you do with waste is very strictly regulated. And as we do, we transport it, we pre-treat it, as you have seen in the pictures, and we make a nice fiber out of it. If we leave it in the legal status of waste, and we bring it to a company who is using that, transport it, and there the facility is using it, then we come again in the same circle, and you also need for that product, the fiber, you also need to fulfill all the waste criteria. So that's why we don't want to do that. The grass fibers need to be a product. So to skip that, we need to get out of the waste status, legal status of waste, to go to the resource end of waste. And that's what we did with our grass fibers. How does it work in Flanders? There is an online, very, very user-friendly platform. And if you start a procedure, you need to keep in mind which end application you want to ask your status for. Because also very important, for every different end application, so if you go to a building material or to something completely else, you need to have a new procedure. But luckily, you can put everything together in a cluster. Why is this like that? Because OVAM is testing it. If you have another end application, there are other security or environmental restrictions. If you're using it for food or for a building material, you need to be more strict for food, of course, than for building material. So that's why every end application needs its own procedure. So that's why you need to put it in clusters. You need to answer the 4 principal questions. Do you have any danger for the environment, or do you fulfill the conditions that the EU has asked for? So you have the sampling and the analysis done by the accredited laboratory, and it's done on the site where the processing is. So for us, it was in the greenhouse. And then you need to ask for the analysis at the VLAREMA application. If the VLAREMA has the quantitative conditions, then you can just give that list. But if you, like we did, we didn't have the quantitative conditions, we needed to think about our own quantitative numbers because it was a new application. So that's what we did. So we we combined a little bit both. So we asked our end users what is important for you as a qualitative analysis, and we combined it what was in the Vlarema itself. So that is what we went through. And it was very important to answer those questions in a good way. But what we encountered and what we found was very difficult if you go into those procedures with a very innovative product. The first question is, sorry, the screen is gone again. Sorry. I lost my screen. So if your application is very innovative and it's not yet commonly used, how do you apply for it, or how do you give some arguments that it's that in future you see a market for it? And so then we come to the second question. You need to prove that there is an existing market or demand for that substance or object. Also here, if you are in with an application that is new, that you want to develop a market, also here you have a bit of trouble to fulfill and to answer these questions. So that's also a challenge. And then the use is lawful. I will give you, for instance, one example. The use is lawful. Of course, we want to apply with the law. But what if a certain new material wants to compete with another conventional material that is made, for instance, out of wood? And there the law or the labels say it's a FSC label or PEFC. But if you use grass fibers, you can't get that label for that panel material. So you want to fulfill with law, but law is not the conventional and existing legislation is not written for your new product. And also there, it's very difficult to prove it. And then the last question, the use will not lead to overall adverse environmental or human health impacts. What we learned here is that LCA thinking and reporting of the end of life of your new product is necessary. And we agree with that, but I want to raise here one critical other question. I agree with that we need to prove that our product is end of life also still safe, but it's more strict in my opinion than for conventional products, because do we ask it also for conventional products? So here we are quite strict, of course, also for that new product. So these are my personal opinions about those four very logical questions, but not so logical if you want to answer it for a very new and innovative product. So at OVAM, we started a procedure for our grass fibers for 3 end users: panel material, mycelium insulation material, and plaster material. The laboratory came to the greenhouse, to our drying facility. We did, or the accredited laboratory did the analysis with the specific, so the specific quantitative norms were not available, so we put some together. We used the one for a soil improver combined with some extras. And then we try to document the 4 main questions, so the principles and the conditions that came out of the law of the framework from Europe. And how we did that, we tried to compare the conventional market and products with what we wanted to do. And we used a lot of the reports of Grassification on yielding, processing, material test, techno-economical calculation to argument our case and to ask for the grondstofverklaring. And what I think helped us a big step forward was that we asked for a temporary grondstofverklaring. That means for the coming 2 years. So OVAM was there also very cooperative and supportive to help us through this beginning phase. And so luckily they granted us for the next coming 2 years our grondstofverklaring. But they are very careful, and they ask some extra information, but we can collect that during the next coming 2 years. So we still need to provide them with an LCA of the end of life of all the different end applications. During the processing of the grass-to-grass fibers, we need to register all the produced fibers, and we need to repeat the analysis from the laboratory several times during the coming 2 years. So that's what we received from feedback, but we received a grondstofverklaring for 3 end applications within this project. So we are very happy and proud that we reached that nice result. So what is our own experience with those end of waste criteria from waste to resource? It is possible, but I have some remarks or critical thoughts about it. The goal, how to manage that as a society or as an administration, it's very noble, but on small value change or local circular value chains, the impact is quite high. It asks a lot of administration, it asks a lot of financial input, and innovation is in some cases a disadvantage, or how do I need to say it otherwise? It's sometimes difficult to ask all the to answer all the conditions. And I said that all those things for a local circular value chain, you burden it quite a lot. So my message or take-home message is, I think it's necessary to have something like that, but we need to find an equilibrium or a balance between all those protecting environment and people, because that's for sure necessary, but also keeping it flexible and feasible for a local value chain in a circular economy. My feeling is, or my opinion is, that how it's the procedure, how it is like at the moment, it's still not completely fit for a circular economy. It's a bit too heavy for those circular local chains. That's what we encountered during the complete procedure. So thank you for listening, and if there are any questions, please ask so.
Thank you very much, Nathalie, for your very nice presentation and overview of the end of waste, and congratulations that you managed to get to the end of the whole procedure. Are there any questions at this moment? I don't see any question.
Yeah, hi.
There's one question.
Let me put on my camera. Thanks, Nathalie, for that, and kudos on getting to the end of the procedure. I was wondering, as they put forward some extra conditions in the coming 2 years, the LCA of end of life of all different end applications, it's indeed quite heavy. To which extent is a grondstofverklaring disclosed to other parties? I think you engage with private parties. You need some confidential information from their end. Is this a fully closed procedure towards, let's say, general public, or are, let's say, your private partners a bit reluctant to share information because the information can be disclosed afterwards?
Good question. They ask quite a lot about the end application, so you need indeed the partners to open up and share it with you. It's not out all open in the public, but you need to share it with OVAM, of course. So that's for sure. And also, that's not completely an answer to your question, but what I learned during the procedure also, if we want to start up another facility, then we need to start all over with the procedure. So if we grow up from our greenhouse to a full-scale facility, the grondstoffenverklaring, as I learned, is bound to that site, and so we need to have it all over again for the next facility. Also, the other way around, our end clients who are making nice panel material or mycelium material, if they want to buy fibers from another producer than ProNatura, it's not because ProNatura has the grondstofverklaring for the grass fibers that another company next door is it also settled there. So they also need to, if ProNatura is copied by another company, then they also need to have the grondstofverklaring. So yeah, it's very yeah, a lot of procedures, or how do I need to say it? Yeah.
Okay, thank you.
Thank you. Are there any other questions? Otherwise, considering time, I do have one question because Natalie, what do you think if we would look at Europe, what would be the biggest step forward if they would have to change the legislation into making it more easy to reuse materials? What would have helped you most?
Yeah, it is very so. Good question. I don't have the solution yet. My first solution, or more to make it more simple, is to now you need to have for every end application a new procedure. I would cluster that into food and feed and others, very simply said. Or you have 3 categories, but not for every end application. I think that would help us one step forward. Yeah, and then yeah, something more. They use a lot of the time the conventional material and the conventional market, but it's not applicable for new things. We don't want. With bio-based economy and circular economy, there are 2 things. You can replace the conventional material, but you also can enter the market from a complete other way of thinking and servicing, and that's not in it. And so they need to think about that also, because sometimes you can't compare it with conventional material. And also there, because LCA is also compare it with conventional.
Yeah.
For sure, we will have some troubles to compare the new materials with what do we compare. So it's all the time comparing with conventional, and I'm like, let's get out of the conventional. We want to go for completely new, and the procedure is not fit. And I see now in the chat that a stepwise risk assessment. I like the idea. Yeah, that would be something, and I think that's the way forward also, because if we go into services materials that is not comparable to conventional things, we will need to do something like that, because it won't be feasible otherwise.
Yeah. Okay. Thank you. Well, you already suggested a few things also before with the question to Ruben. I think there are some interesting things to think about. So thank you again for your presentation. And then I would like to start the first poll question, and maybe I will get back to you, Natalie, because I think it is linked to the presentation that you gave. So Maarten, could you please present that?
Is everyone able to see it? Very good.
Well, my internet apparently is slow, so it's still starting up. Because Natalie talked about legislation, but the question is, there are more challenges in making the reuse of grass fiber a success, and I was wondering which of the 5 that I could think of do you think is the biggest challenge for us to, or 6 even, yeah, so I missed one. And I'm curious about the outcome, because I was on a webinar last week in the Netherlands, which was also about the reuse of materials, and I know the outcome of that one, and I would like to see if the audience has a different opinion here. I'll wait a few more seconds, but I see we already have 22 responses, so that's very nice. Okay, and I can see that, well, based on your, maybe based on your presentation, Nathalie, but legislation ended up first with 29%, and then the market and the quality of grass. And which is interesting because, as I told you, the webinar was last week, cooperation was number one between the different partners in the value chain. So from the people who provide the grass up to the people who buy the end material in total. Would you like to respond to the outcome, Nathalie? Any thoughts on this?
Yeah, I would like. I think I biased a little bit the poll because I talked a lot about the problems. About the cooperation, I can't complain about that because that went quite well. And I know the quality of grass, it's not the issue of this webinar, but yeah, that's still also for ProNatura one of the big challenges. So I agree with the 22%, and for me, it's equally, perhaps even a bit more with the legislation. If you, yeah, like it went all right, but it's quite just heavy, but it went all right. Ovan was quite supportive. I need to stress that. So yeah, I can see why legislation and quality of grass are the main issues.
Okay. Thanks very much. And then, well, this also leads for me a step to the next speaker. So thanks again, Nathalie. And our next speaker will talk about the products we can make from grass fibers. So our next speaker is Harm Tiwis from Milvision. And Harm has a degree in polymer chemistry and analytical chemistry, and he's an R&D product manager at Milvision since 2013. And there he has developed expertise on modifying natural fibers and different types of biomass to be applied in all kinds of applications in paper, cardboard, biocomposites, and bioconcrete for both construction and infrastructure applications. And today he's going to tell something about making thermoplastic biocomposite compounds using roadside grass, and especially for landscape infrastructure applications. So I would like to give the floor to you, Harm, and maybe you can also, when you look at the poll question, what is your opinion on the outcome of the poll as a start?
First of all, Jappe, thank you very much for the very nice introduction. Yes, regarding the poll, coming back to that one, I think it's a combination. I think we're used to, if you buy materials, we all know the specification, but having natural products, what you see, that can change from year to year depending on the season. Besides what we have seen, and which is also a clear problem, the general public and the legislation, people are thinking in a certain way, and that needs to be changed. Generally speaking, what it should be done, if you have a new product, it's asked for new approaches, and yeah, that's sometimes difficult. And I think that was made very clear by Nathalie de Vriend in the previous presentation, that these kinds of things are not easy, and it takes time due to the fact that people are thinking in an old-fashioned way, unfortunately.
Okay, well, thanks. Very clear vision on that. And then I would like to give you the floor for your presentation.
Okay. Well, I will take you into the world of the thermoplastic biocomposite compounding and making profiles out of it to be used for landscape infrastructure applications. Why are we mainly focused on thermoplastic biocomposites? We have chosen for these type of materials that end of life. They can easily be shred and it can be reused in a new application once it has reached end of life. The first thing that we have been focused on within this project was the following. You can harvest grass during the season at certain time slots. And to have these resources available during the whole year, yeah, then it's nice that you have your material forehand and that you can take whenever you would like to have this material. Then you can just cut the grass and put it in bags and store it. But grass by itself is rather voluminous. So therefore, we have been focused on making pellets out of it to reduce the size, and also from transport point of view, to make it more compact. Yeah, to bring it at certain locations where you would like to use your material. The nice thing of making these kinds of pellets, it's depending on the process conditions that you are making these pellets. And that's also depicted in the images. There is one image is missing, and that's even at lower moisture content. What you can see, if you are having too much moist still present in your grass fiber, you're not getting nice compact fibers, but it's more fibrous-like. Whereas on the other side, and that's even you're going even to lower moist content, and then you're talking about roughly 10%, your pellet is transformed not longer in a pellet, but it will transform into powder, which you don't like either. After we have made these pellets, we have tested different types of roadside clippings. The standard roadside clippings has been provided via Pro Natura. Via Delphi, also one of the partners, we have looked at different type of grass fibers, which could be of interest once they should bring extra mechanical properties. And if this was the case, then it could be nice to make cultivated roadside grass next to towards the road. And we also have looked into digested grass. Otherwise speaking, you're taking out the disturbing substances, then you need to think about sugars and proteins, which may disturb during the compounding process. Based on these different types of grass, we have worked on different recipes, making compounds. But first of all, what we've seen in the grass that we have received, it's still got a lot of pollution. You can imagine that if you would like to process further on, either pressing it, whatever metal process you use, that you don't like to have sand or stones or metal into your resource material. So therefore, we first clean the grass, and thereafter we've tried to process it into different recipes. By making these kinds of recipes, at a certain point, we did mechanical testing on all these kinds of compounds that were made by making test bars and analyze these test bars. And based on these outcome, a best recipe was depicted using the roadside clippings, and profiles were made at one of our partners, which you see on the right bottom side, with an extrusion technique and ending up in a 10 by 10 profile with a certain length. Then we went over to the next phase, and we've made sketches of different families of picnic sets. And first of all, internally, we decided within Mill Vision what is a nice family to go further with. On the right side, you see the rather common picnic set, which is also made from wood. But on the upper left and bottom left side, you see more materials, and of course they can also be made of wood, but they are more framed to be used, making them with biocomposite materials. Also of these materials and picnic sets, we made an artist impression, and that was mainly done to be used towards our observer partner, Rijkswaterstaat, but we also consulted a contractor, and that's normally a person who is hired either by Rijkswaterstaat or by another partner to install these kinds of benches, and to learn from them together with Rijkswaterstaat what are important factors which we need to take care of once we would like to install these picnic sets. And based on this one, we made some kind of a table by using the factors which were handed towards us by the observer partner Rijkswaterstaat and by one of the contractors, Maurik Groot-Amers. And one of the things that needs to be taken care of, it should be easy to install, but it should be also, that's called hufter-proof, so otherwise vandalism-proof. People are climbing on it, standing on it, maybe not with one person, but maybe with 20 persons. It should be safe in use, but it should be also easy to be handled regarding maintenance. And based on this table, diverse sketches, a single bicycle, a double bicycle, single car, double car, etc. The COVID 1.5 meter picnic set were put in value based on these demands of the observer partner and the contractor. And based on this table, it was decided finally to go further with the 1.5 meter picnic set. And here is the final end result of this first prototype picnic set material. At the moment, it's standing at the backyard at Mill Vision, as you can see. And at the moment, we are monitoring to see how material will behave in sunlight and also in the real weathering test. Having rain, having temperature fluctuations, and so on. And once that's looking great, then probably we will go back to both the observer partner and from Maurik Groot-Amers to see whether they are interested and whether it should be installed somewhere. So at the end, thank you for your attention, and if you have some questions, please, let me or my colleague Fransje Voets know. Thank you for your attention.
Thank you very much, Harm, for your presentation and a nice end result of the picnic table. Are there any questions for Harm? I see one hand raised. Ruben?
Yeah, thanks if nobody else wants to go. Thanks for the presentation. I was wondering, you mentioned fibers being used also from 3 parties, including Van Hede. Does this mean that the fibers from Van Hede also were in line with, let's say, the technical properties that were needed to co-extrude?
What we've did is, and we're still working on it, what you can imagine is during the digestion process, disturbing substances like sugars and proteins are eaten away in the process. However, we need now really to find an optimum, and it's dependent on the process, because on the other side, by these compounds, you're making biogas. So you need to find to a certain right optimum that it's still worthwhile to get enough gas out of the production. But you can also imagine that if you put it too long in the digestion system, that besides the disturbing substances, sugars and proteins, also the fibers by itself can be degraded. And what we've seen so far is that the digested grass was at that stage, then when we were testing, was not the best option. But I can imagine that in future, this needs further optimization. And if you find the right conditions, that it's convenient for generating biogas, and it's convenient to make thermoplastic biocomposites out of it, yeah, then you really have a win-win. But that stage we are not yet, and yeah, that still needs to be proven.
Okay, so for the moment it's not first pick, but we need to develop further.
We need to further develop this.
Okay, thank you.
Yes.
Okay, thank you very much. I see there's another hand raised. Leon, you can turn on your camera.
Yes, can you hear me?
Morning.
Yes, we can hear you.
Okay. I have a question about quality criteria in the raw material or in the end product. Are there certain requirements? What can still be there? Because from roadside there can be pollutants inside the material. Is that clear? What are the criteria?
Yes, within the project we have had quite some discussions, and I think the real challenge in this whole exercise will be, even that you set criteria, we also have the mowing part, which maybe are now underlighted, but even if you give them these demands from the local government, they get also requirements regarding that they need to mow a grass in a certain time frame. So yes, maybe if we give the right specs to them and we are there, they will mow according to our specifications, but as soon as we are gone, then probably the specs will be regarding making money, and so there is some drawback between these or some fights towards these two positions. What is definitely clear, and I think that will be in any processing, whether it's washing, whether it's extrusion, whether it's pressing, whether it's whatever, it needs to be excluded from sand, stones, metal, etc., because you're destroying your equipment. So it needs to have a cleaning part of it.
Maybe I have to more clear. I'm talking about the components inside the material, not the big waste, but like metals and other things which are inside the material, which can also give problems in recycling after your end product has finished its lifetime, for example.
Yes.
So that is a different question.
The other question, if you're regarding the and that was also the part that I was why we decided within the project to go both for digested grass and for the grass as is, that this might be giving answer towards your question as well. If we take out these disturbing substances, because sugars are small molecules, yeah, probably hardly bringing anything. That's the same with proteins, having and now it's getting chemistry-like, but having nitrogen components. If you put heat on it, you have maybe chance of making gas formation during the processing. So if you could take out these disturbing substances, maybe you're then getting a better end product. But unfortunately, there is also another action taking place, and that's if you are too long with your grass fiber in the digestion system, you're also degrading your fibers. So we're not at this stage to say a clear answer to your question that the disturbing substances, which I have a feel that is the case, that if we take them out, that we then have a better product. But I would like to have this answer as well as you like.
Maybe you should continue the discussion later, because considering time, I would like to go to our next speaker. So thanks again, Harme, for your presentation. And if you look at the schedule, don't worry, we had questions and answers at the end, but I decided to do them after the presentations directly because I think that fits a bit better. So we should still make it before 11:30. So I would like to introduce our next speaker of today, which is Dries van Steenkiste. And Dries, he holds an MSc degree in Biosciences Engineering at Ghent University, and he has a PhD in Forestry and Wood Sciences at NGREF in Nancy in France. And since 2014, he performs biomaterial research and coordinates the research projects at the Fashion and Textiles Innovation Lab of the University College of Ghent, Ghent in Belgium, where he also lectures. And today he's going to tell you something about the use of roadside clippings to biocomposite building blocks, panels, mats, and tiles. So I would like to give the floor to you, Dries. You're on mute at this moment, so.
It's the first time I do a webinar. Okay. Everybody sees the screen?
Yeah, we can.
Okay, I will go to projection mode. I would also like to thank my colleague Laurie Charles, who has contributed a great deal to the development of the prototypes that will be shown in the presentation. So I will, after a short introduction about the background, show you some examples of the biocomposite building materials and landscaping materials that we developed in the framework of grassification. We estimate that in Flanders, so in the map you see the project area of the two C's, Interreg area. In Flanders, we estimate that at least 50,000 tons of roadside clippings in terms of dry matter are produced, harvested each year. A part of that, a great part of that is collected, might even be much higher. And as Nathalie had said, these are available at two peak periods in Flanders. It's in June and September. During a short time, so a huge volume of grass becomes available. If we want to process that into materials, it's a huge technological, logistical challenge. But of course, we had also great expectations, because as these roadside grass clippings are also lignocellulosic material, they contain lignin, cellulose, and hemicellulose like wood. We thought that they could be a substitution material for wood. There are already examples of grass fibers being used in pulp and paper, also in construction materials, besides other natural fibers like hemp, for instance, hemp chives. Since it's a lignocellulosic material, it also has biorefinery potential. Besides that, it stores carbon, CO2 from the air. We call this biogenic carbon. For each ton of roadside clippings, we estimate that about 1.5 ton of CO2 equivalents are stored in the raw material per dry ton. Compared to wood, that's about similar. Grass has a somewhat lesser carbon content, 40 to 45%, due to the higher ash content compared to wood. But in general, we can say that organic materials contain between 45 and 50% of carbon, if you exclude the ashes. And then finally, it has a certain bioenergy potential. The lower heating value, so if you would combust the material, you can produce about 18 gigajoules of energy per ton of raw material. Wood is comparable, slightly higher, because it usually has higher lignin and lower ash contents. This was used to the advantage in the project also to produce biogas, which I will talk about a bit later. So a roughly estimated for these 50,000 tons of roadside clippings, we could theoretically replace about 100,000 tons of wood, roughly measured, with the quality and properties of wood being slightly better. So the scale is still going to the side of the timber or the wood. For the prototyping experiments at the University College Ghent, we proceeded always with the same, or roughly in 3 steps. We were dependent on the grass clippings that were provided by other partners in mowing experiments. So the grass was delivered usually in these blue barrels containing about 20 kilograms or 120 liters of grass fibers, which were moist depending on the type of grass. And then these were pre-processed, dried. We'll talk about this in detail in the next slide. And finally, we had the actual prototyping. Here's an example shown of a pressed fiberboard panel that was produced in using the laminating press of the University College Ghent. So I will now go a bit into detail for each of these 3 steps. First is the collection of different types of clippings. We worked with different types of grass, which were provided by the working package 1 partners, in particular Pro Natura, and several mowing experiments were done, and some pre-treatments in this upstream step. So the basic type of grass roadside clippings we worked with were air-dried fresh roadside clippings, which we can label as hay or straw, which contains long and short fibers. Then we had also grass provided from a pressing experiment. So fresh grass was pressed with a Dutch installation machine, a screw press, and liquids were separated from the press cake. So we did also experiments with that material. And then finally, we had the anaerobically digested fresh grass in a small scale and a large scale experiment performed, the latter at Van Hede. The scale was between 300 and 500 tons. And the first goal was to, of course, to produce biogas, extract the components that are of less value or could be harmful to the biomaterials, in particular, the components that are easily digested by microorganisms, such as sugars and proteins and fats. So these are extracted and converted to biogas. Also, of course, a part of the lignocellulosic material is converted to biogas, depending on the degree of digestion. So we obtained there what we call pulped fibers. Then the next step was the pre-processing. Unlike mill vision, we did not grind or mill our grass. We just reduced the moisture content after sorting and subsampling the grass. We had also, for the anaerobically digested grass, had a washing step. And we performed indoor drying. So no, we did not use extra energy. We just let it dry indoors. And we managed to reduce the moisture content that way to about 15%, 12 to 15%. It fluctuated a bit at the end, depending on the air moisture. So we started with fresh grass of about 85% moisture. Also the press cake, which is somewhere in between, so about 50%, 40% of the liquid had been extracted. And then the grass that provided the dried air-dried grass had about 25 to 30% of moisture. But for the experiments, we needed grass that was fairly dry, so in the range of 12 to 15%, except for the mineral experiments, which I'll also show later. So one of the steps was also sieving. We wanted to look at the different fractions that were present in the grass supplied, and so we separated it in 3 fractions: the straw fraction, which are the longer and coarser fibers, then a middle fraction, which we call the pulp fraction also, with short fibers up to a few centimeters, and finally the smallest fraction, which is a dust fraction containing organic and mineral material with fibers of less than 1 millimeter. So this gave us a range of raw materials which we analyzed chemically. Here you see a graph at the bottom right showing the variation in ash content per kilogram, going from 50 to 45%, so 5 to 45%, and a range of cellulose going from 10% to over 60%. So then we proceeded with the actual prototyping experiments. We have developed 4 types of prototypes. The first one being bio-based fiber boards. For this, we manually laid out a dried fiber mat in a mold under the laminating press. We applied bio-based binders, different types of bio-based binders. We tested some combinations also with hemp, and then we subjected the grass to a pressing during about 10 minutes at 150 degrees. We started with small scale samples of about 10 by 10 centimeters, and then upscaled this to A4 format. And finally, we managed to produce panels of about 60 square centimeters by side. The thickness ranged between 3 and 18 millimeters, which the latter is the commercial thickness of wood-based panels. Here are shown some examples of these panels. So we had lightweight panels and more dense, heavy panels. The density ranged from about 250 to 1,250 kilograms per cubic meter. Depending on the amount of resin that was used, which type of fiber fraction that was used, coarse or finer grass, and of course on the pressing intensity, which was also visible by the variation in the thickness of the panels. Here are shown on the right a graph showing the different amounts of resin that were used, going from 0 to 50% in mass fraction, and the resulting densities going from 250 to over 1.2 grams per cubic centimeters. So we noted that with less than 5% of resin, we could not obtain a structurally bound panel. So minimum 5 to 8% of resin is required to obtain bonding. The second type of material was the mineral building blocks and beams. We used variable amounts of grass, also hemp shives, mixed with lime to produce a product that's comparable to hempcrete or hemp lime construction walls, which could be labeled grasscrete. There were some disadvantages to these products. They required very long drying times, several weeks, during which sometimes mold was produced on top, on the outside of the material, and also visible discolorations in the grass inside the material. Of course, this material has limited load-bearing capacity compared to concrete, especially reinforced concrete materials, but we could achieve some reinforcing by adding other plant-based material with tensile strength to the material, as was the case in the beam showing on the right-hand side. So this beam is about 10 by 10 centimeters and 1.5 meter long.
Please, could you try to round it up?
Yes, yeah. I will speed up a bit. So, of course, this material can store CO2 for a longer time. It allows moist processing, so we don't have to dry the grass to a very low moisture content, and the ash is no problem, as are other contaminations. A third type were needle-punched mats. They were performed on a semi-industrial equipment in Germany, with a needle punch width of about 60 centimeters. We tested several combinations of grass and hemp fibers. Important to note is that we had to re-moisturize the grass because the dry fibers are too brittle. With this material, we performed an outdoor test during 3 months to test the cohesion and the functionality in weed control experiment, comparing it to commercial alternatives. And finally, the last prototype is a roof or a floor tile material. You see on the right-hand side how it was made in cross-section. So we stuffed a netting fabric with grass fibers mixed with a bio-based binder, and which was also pressed to this tile shown at the bottom. So this tile is about 70 centimeters by 25 centimeters wide and about 2.5 centimeters thick. I will skip this one. These prototypes were integrated in a demo construction setup, and we are about at a technology readiness level of 4 to 6 at this stage. So no commercial products yet, but we are moving closely. There are still some legal hurdles. If you want some more information, I'm available for questions. And I also thank the other partners, of course, in the project, and the financial support of the European Fund for Regional Development. Thank you very much.
Thank you very much, Dries, for a nice overview of the different products that you developed. About questions, I would suggest that if you have any questions for Dries, you put them in the chat, and he will be gladly to answer them, I hope. Because considering time, I would like to go to our next speaker, who is Willem Butger. And Willem is a professor of the research group Bio-Based Building at the Center of Expertise Bio-Based Economy of both HZ and Avans University. And next to being a professor of this research group, Willem is also an entrepreneur and director of innovation in NPSP, where he's developing and selling bio-based composite materials and products. And what's nice to know, NPSP developed a bio-based street signs furniture in 2011, and he won the Gold Excellent Enterprise Award from the Dutch rubber and plastic industry on this. And today he's gonna tell you a bit more about the development of grass-based tropical hardwood replacements. So the floor is yours, Willem.
Jappe, can you see my screen?
Yes, I can. Yeah.
Okay, perfect. Thank you very much for introducing me. So we're also part of the Center of Expertise Bio-Based Economy. Our goal within this Grassification project was to develop a 100% bio-based material that can be used outdoors to replace tropical hardwood and also aluminium, but that's easier to replace from a sustainability point of view. And we wanted to demonstrate this material in facade cladding and in a knuppelpad. I will explain later what it is. When we look at waste fibers in composite materials, it's very important to see what is the value of these fibers compared to the fibers we're using at the moment. So in composites, glass fibers are being used, and if you look at biocomposites, flex fibers are being used. So the first step is to evaluate, are these grass fibers, do they have comparable strengths, so mechanical properties over the price? So if they're much cheaper and the mechanical properties are much lower, then you can have an interesting material. So the value over price is very important. Value is not only mechanical properties, it's also lifetime expectancy and, for instance, shrinkage or weight. So there are more sustainability, more aspects to look if you look at the value. First step, what we did is we compared grass fibers with other waste fibers that were offered to us. So we compared grass fibers with recycled toilet paper fibers, sugar beet root pulp, and another type of fiber of wood. And on the left upside, you can see the fibers. And we mixed them together with different types of resins and fillers to make composite materials. And we made some test samples, and we tested then the mechanical properties. But first, what we did, we looked at how much cellulose is within the fibers. So the cellulose gives the strength to the fibers, and you also have the hemicellulose and the lignin and pectins within fibers, but the cellulose is the most important. And next to the cellulose, you have different types. You have amorphous cellulose and crystal cellulose, and the crystallinity is also very important. So if you want to make strong and stiff products, you need to have a lot of cellulose within your biomass and as much as possible a high crystallinity. So what we did here was we have the same fibers, so the sugar beet and the recycled toilet paper, and we looked at the cellulose content and also at the crystallinity index of this cellulose within the material. So if we look at grass, we can see that roughly 45% of grass is cellulose, so that it's pretty good. It's not the best, but it's pretty good. It's much better, for instance, than sugar beets, but it's lower than recycled toilet paper. And if we look at crystallinity index, then we can see that the grass has a little bit more than 30% crystalline cellulose within it, and that's, for instance, much better than sugar beets. So the value, if you only look at the fiber, will lay between sugar beets and recycled toilet paper from a mechanical point of view. The first experiment we did, and this is not 100% bio-based, so here we combined grass fibers also with other fibers, but mainly grass fibers together with calcium carbonate, which drinking water companies distract from their drinking water to make the drinking water less hard. We combined it with a bio-based, partly bio-based polyester resin, made some sort of dough out of it, like you make bread, and compressed it into tiles. And these products were presented in Dubai in a competition of universities, technical university, and this was a house which was being developed by the students from the Technical University Eindhoven. So this was a first experiment in which we used grass fibers next to flex fibers and recycled textile fibers. And what we learned from this project, that it's possible to produce these types of materials. But the goal was to go for 100% bio-based. So we made different types of samples together with 100% bio-based resin. The sample up on the right side, that's natural, or a grass fiber with a natural-based resin, a furane-based resin, so that's 100% bio-based. And what we did, we put these samples in an accelerated weathering tester, so with high moisture and very high ultraviolet light coming on the samples. We measured the mechanical properties in the beginning, and then after 1,000 hours in the accelerated weathering tester to see if mechanical properties remain the same or that they go down rapidly. So this is a very important measure if you want to use these products outside in the weather. And the good thing of these samples were that the lifetime expectancy of the grass fiber together with this furan-based resin is very good. It was much better than the other resins we tried to use. So that's a good step. Then we go to the knuppelpad. So here you see some examples. It's a wooden path over which you can walk when it's wet below, so you will not get wet feet. And so it's very important that these elements are good resistant against ultraviolet light, but also against humidity. So the tests we did in the previous slides are very important for these products. There's two potential techniques if we want to use grass fiber and make this knuppelpad, a plank out of it. And the technique one is pre-pragging. And what you do for pre-pragging, you mix longer fibers, say grass fibers are 6 to 10 centimeters. You mix them and needle punch them. That was in the previous presentation. It was being shown that they did in Germany a pre-pragging of these fibers into a mat, a non-woven mat you call it. Then you have to put this non-woven mat through a bath of resin and then get rid of the extra resin and compress the element in a product. That's technique one. And then you have technique two, that's called bulk molding compound. You have higher pressure and the temperature is roughly the same. You have lower mechanical properties than the pre-preg method, but you have very high form freedom. So you can make ribs in your product to reduce the amount of material. For this technique, we need smaller grass fibers, 6 to 10 millimeters. So that's much smaller. And we can combine it with Japanese knotweed or another filler, but we chose to use this because this is also a waste material and it's pretty hard material. You need, as a filler in this technique, a hard material. So in the facade I showed it was calcium carbonate, and here we replace it by Japanese knotweed, which we also mill to very small diameter. Then we combine it with the resin. We make a dough, and we can compress the dough into a product. So here you see the pre-pragging method as is being used in industry. For instance, in flax and hemp industry. The challenge with grass fiber is that grass is rather brittle, so that they will break sooner. So it's tougher to introduce this method, but still from a mechanical point of view, it's an interesting method. And the other method, so number two, that's the BMC. There you combine the fibers with the filler and the resin into a mixer, and you compress it into a product. And at the end of the lifetime, you can shredder it, so you can mill the material and use it again as a filler. So that's, in fact, it's a downcycling, but still it's a nice circle. First prototype we produced, this was not with a mold, it was with a simple mold, and we glued the elements together. And what we're doing at the moment, we're redesigning this plank. And then one redesign is with the pre-pragging method in mind, and the other one is with the bulk molding compound. So with the bulk molding compound, for instance, at the right side, you can see you have a lot of form freedom. So it's easy to make a product with lots of ribs, and don't put material where you don't need the material. So to optimize the use of material, to try to beat tropical hardwood in a value over price way. So that's what we're doing at the moment. We're also setting up now a production line within Avans in Den Bosch. So here we're going to produce these elements with the different types of techniques. We're doing research also on the business case of these two techniques. So what are the investments, what are the production times? And we're also looking at the two different life cycle analysis of the two planks, because they will have different investments in energy and CO2 footprints, etc. So that's what we're doing at the moment, and we expect to finalize this over October coming. So that's what I wanted to tell to you. Thank you for your attention. I think a little bit room for questions.
Willem, yeah, indeed. Yeah, there's time for a question. Is there any question from the audience? I don't see any hands raised at this moment. Well, maybe a question from me, because now you're making the planks. Do you also see other applications with the same type of material?
Yeah,
the planks.
The planks is a very tough, because a plank is a flat panel, and flat things are tough to beat because there's enormous amount of flat products on the market. So double banded products will be much easier because those are tough to be made from, for instance, tropical hardwood and even from aluminium, etc.
Mm-hmm.
But organizations like Pro Natura, they have grasp, but they're also willing to buy products. And this would be also from a circular point of view an interesting case to look at it. But it's very tough because hardwood they use in Belgium is coming from Belgium and France. It's oak. In the Netherlands, we buy a lot of tropical hardwoods, so from South America. I think it's more interesting to look at biodiversity loss in South America. And of course, you have to look at what are you doing with the grass if you're not making a plank out of it, what is currently being done. So, and compare these things together. But there's a lot of more options to produce facades or whatever.
Yeah. Okay, thank you. I see you have one more question from Dries, and maybe yes. Maarten, you can already introduce the second question I would like to pose to the public. So the floor is yours, Dries.
I was wondering the support on which the planks are mounted, that's made of a different material, that's made of wood or also of the same, so you don't have water contact directly with the planks or ground contact with the planks?
No, at the moment we focus on one product, so that's only the plank. Mm-hmm. And for the carrying structure, you would need longer elements. So then other techniques are more interesting than pressing, because when you need, for instance, the BMC process, when you need 100 bar pressure, then you need extremely big presses to produce it. So that's not the focus for the moment. For the next project, maybe, because then you need a more pultrusion line, like. Was the process with the thermoplastics is then more interesting, I think, but you can make endless elements.
Okay, thank you very much. Then Maarten, could you maybe post the second poll question, because now we have 3 applications right now, I think. Shown which we made in
I see one question, maybe of Christian.
Oh, sorry, Chris. Sorry, I didn't see you raise your hand. I only saw you in the screen. So if you have a question, then...
In Grami term, I tried to take up contact, Christian, with your company, but you have a different type of needle. It's not needle punching, but I think it's, how do you call it? Blow mixing of grass fibers.
No, in fact, we mix fibers and we use the airlay technology.
Yeah, so I'm very interested in your, but your technology is trying to get a thick layer, because you want insulation, and I want the fibers in a flat layer because I want to have mechanical properties.
Gramitherm is really a thermal insulating batt.
Yeah.
So we are in with a 40 kilo density, and we do produce and market insulation mats between 40 millimeter thickness to 240 millimeter thickness. Okay, so that is really the Gramitherm definition.
Yeah,
and we have here a newly installed line with a huge capacity now in Belgium. Yeah.
But would you be interested in doing a needle punch experiment?
Well, this is my message to the Grassification group. we have a technology, we have a plant, and I will be very happy to welcome you guys to make some tests. We have, of course, we have some limits to the system, so we are unable to produce rigid boards. Okay, we can go to 100 kilo per cube density. So we are not in the rigid boards production. This is we are really with the insulation product. So this is air containing, and this is opening and mixing fibers. This is our job. But yes, you can contact me. We can give you access to the plant, of course, with a confidentiality agreement duly signed. And I want to be sure that, okay, Gramiterm is a friend of Grassification, but I insist that regarding the light insulation technology, matte, we are already on the market with this type of product. We have our own patent technology. So I don't want you to create a misfit here or confusion by developing similar product to what we do, because in that case we are no more and no longer friends.
But the product you saw, it's a plank, so it's completely different than from an insulation material. But I really like to chat with you because you made some steps which are interesting for our process as well.
Okay. Yeah, absolutely. So feel free to contact me, and always all the team here and from Grassification you're welcome at the plant, and it will be a pleasure for me to contribute to added value with this roadside grass. This is our mission, and we are pretty well advanced now because we are no more in the research, but we are in the business, making huge progress now. So this is interesting for you guys.
Okay, thank you very much for your offer, and I think well, we made contact now. I think it's very good to cooperate on this, and indeed we are not working on insulation. That's not one of the focuses on the Grassification, but we're happy to collaborate. So we'll be sure to contact you.
Hey, thanks, Jappe. Thank you
very much. Well, considering time, we will be delayed, I think 5 minutes, hopefully. But I think they're very interesting presentations, so I hope you will stick for a few more minutes. So thank you very much, Willem. And I would like to introduce our final speaker of today, which is Hanne Schatteman. Hanne started her career at INEOS after graduating her Master of Science in Chemical Engineering from UGent. And she worked there for 3.5 years, if I'm correct, in various roles. But last March, she made the decision to leave INEOS and join the startup Circular Matters as a project and operation manager. And today she's gonna tell you something about high quality rigid materials from plant-derived sources. So, yeah.
Hi, yeah, can you hear me?
Yeah, I can hear you, Hanne.
Okay, perfect. And you can see my screen?
I can also see your screen, yeah.
Okay, great. So I'll try to make this a bit quicker, not to keep you here for lunch, guys. Good morning, everyone. My name is Hanne Schatteman, and I am the Project and Operations Manager at Circular Matters. Today, I will introduce you a little bit what we do and how it relates to this webinar, of course. But maybe first a few words about Circular Matters. So we still call ourselves a startup. I think we are. We're currently running our pilot plant, and so we're bringing out our first commercial products. That's basically where we are. So what we actually produce, let's see if this works. Yes, it does. So what we actually produce are strong, rigid, and beautiful materials out of plant-based side streams. So these typically come from, for example, the food industry, but also from seasonal mowing activities like the grass we're speaking about today. The materials we create are fully bio-based, they're biodegradable, and they're also recyclable. So in that way, we want to offer a plant-based alternative to synthetic resins and plastics, for example. So to produce our materials, we basically mix two side streams together, one that acts as a natural binder and one that exists of natural fibers. And we basically press them together in a shape or a form. The natural glue keeps everything together, while the fibers provide additional strength and toughness. I think it's quite similar to some of the processes we've seen before this. So like typical fossil-based plastics, our materials are also 3D moldable. So that makes the application options virtually unlimited. Where you would typically use a wood panel that has a synthetic resin, for example, an OSB panel or plywood or something like that, our 2D polymer panels, biopolymer panels could take its place. And where you would mold synthetic plastics into a shape, our biopolymers could be formed into that exact same 3D shape. So on the screen now, you can see some of the applications we have produced already. At the moment, however, for our panels, we're directing a little bit more towards the market of the circular modular walls, for example, those systems, and also retail interiors. So you can see here we've made the kind of design fruit bowl out of it. So that's the 3D formed one. We also have the phone case, and then the two next ones are retail interiors. So BioPlanet is using our materials, and then also the furthest to the right is a work in progress, so it's not fully finished yet. But that's a store of Circuits, which is a concept store of Kringwinkel in Antwerp that will open, I think, this Friday. So if you want to go and have a look, you can see our materials in action. So a bit more about what we're talking about today. So the fibers, a lot of these processes have already been talked about, so I will go through pretty quickly. But basically all types of fibers we use go through this similar process. So there's mowing, then they are gathered or transported. They could be pressed. We've worked both with like just regular grass fibers, and with fibers that have been pressed to get the liquids out, and the liquids can be used for other things. I think that's the webinar somewhere in July that talks about this. But we're also able to work with the residue from that pressing process. So after that, there's drying. Also here we need to have a moisture content of about 12 to 10%, 10 to 12% of moisture. Our fibers are typically shredded to a size that we can use. Possibly they need sieving. I'll go into that a little later because that's one of the important ones for us. And after that, there's again transportation and storage. So just a few words about the challenges we see especially with grass fibers, and especially the ones from the side of the roads. First of all, there's the contamination. So sometimes, of course, next to the roads, people throw plastics or even metal scraps or other stuff that shouldn't be there, but it is there. And of course, we are trying to produce a fully bio-based product in which these contaminations, of course, have no place. And also, like is mentioned already before, for our equipment and machinery, any small piece of metal can do some real damage. So that's very important to get out. So our partners are doing a great job on that, but still, sometimes we find something in there, and to have to sift through the grass manually and take those things out is very labor intensive. So that's definitely a point of attention for us. The size of the fibers, I said in the previous slide that we typically shred, or our partners shred grass fibers for us. Our ideal grass fiber is between, I would say, 1 centimeter and 3 centimeters. If you try to make just general clippings smaller, you end up with a lot of dust. That's a problem Pro Natura has come across by trying to make us the ideal fiber. And dust is a problem for us because it doesn't add any strength and basically makes our materials more brittle. Just because it's there and it's not doing anything, it's not binding, it's not strengthening or toughening. So for us, that's an issue, and that's also where the sieving step comes in. Now, of course, if you shred your material and 50% of it is dust that you cannot use, then where's the dust going? So that's not yeah, we haven't found the perfect solution there yet. So bulk density is the next one, and that hangs together, of course, a little bit with the size. So the discussion that Gramitime just put up, they use the longer grass fibers. I think they like the fluffy fibers because they need air in between their fibers. We don't want air in our fibers. So that's why we typically need a high bulk density, and that's quite important for us. So moisture content, already mentioned this. Typically, it's not a problem. So at the moment, the grass fibers, for example, are dried in the greenhouse, and that works perfectly. But for scaling up, that could become a problem, although Pro Natura is on it, so I don't have any doubts there. And then I put seasonality, because of course, grass, like it's already mentioned also, it comes in peaks. So there, as a company, we are going to have to make some choices how we handle this. Do we want to store grass for a full year, or do we just go with the flow and try to follow the seasons of nature? And in summer we produce panels with grass, or in winter we produce panels with reed, something like that. We haven't figured it all out yet, but that makes it interesting, of course. And then, of course, there's the logistics, because this all sounds very, very great, and we're used to working with grass and it works. But when we will have to scale this up, it will be, I think, a whole different story, just the logistics, but also the storage. And this is something, yeah, I think in the first presentation there was talk about making pallets of it. That could be a nice solution for this problem. So so it's still some work to be done there. So these is a bit of an overview of our challenges we have with grass side from the roads. And but I just want to make the point that all these challenges can definitely be overcome, and they're also worth overcoming, because if you look at the results of the materials, which you can see here a few pictures of, this is from the Bioplanet store in Eigenbrakel from Colruyt. Yeah, Colruyt is one of our first customers, and they've yeah, they're quite happy with how these materials look. They're made from grass. And they will also, well, they made the promise to start using our materials in the interior design of every new store or store that's refurbished. So there's definitely a demand, there's definitely a use, and there's, well, it looks good, right? That's at least my opinion. So thank you for your attention. That's what I wanted to say about Circular Matters and what we do. So if you have any questions, just shout, but you can also visit our website for more information, or get in contact there.
Well, I hope we do not all start shouting, Hanne, but thanks very much for the
raise your hand, sorry, raise your hand.
And I have to agree that it looks very nice, the pictures that you have shown. Well, we have time for one question. Is there a question from anyone in the audience? And I'm happy to see that most people have stuck.
Me too.
Yeah, because it was a very nice presentation. Well, maybe then I'll have one question. You gave a whole list of challenges, which well, I recognized, I must say. We also saw them in the Grassification projects. What do you think is the biggest challenge for you if you would have to choose?
I would say for us, it's the technicalities of the grass. So getting it to the right size that we can work with it, but that's because of the processes we're working with at the moment. That could be potentially be improved from our side, but also, of course, from the side of the provider. So, for example, ProNatura, which is a constant back and forward that we're doing. So that's at the moment our biggest focus, so our biggest challenge, but that may be a bit short-sighted.
Clear, thank you. I see that Dries, you also have a question.
Yes, I was wondering, in the poll, few people had chosen price as a limiting factor. Could you give us an indication of the price of the end product, like the ones you showed in the Colruyt shops?
Yeah, so at the moment, the end product is still quite expensive, especially for Colruyt. They paid definitely a premium, but that was because also they knew they were sponsoring our developments.
And how does that relate to the price of the raw material, the grass? Because from the information I get, it's very costly to harvest the grass. That's in the first step. And then all the processing steps, drying, they cost energy. You add lots of cost to the material.
Yeah. So
I was wondering. One number I heard was that we would be in the range of 200, 300, 400 euros per ton of grass, dry ton, already for the raw material. So that would suppose that the end product the price is much higher still than that.
Yeah, so our materials are definitely in the higher tier material use. But I must say that the fiber is a factor, but it's not the main factor or the determining factor of the price of our materials. So it's definitely, I mean, it's not cheap for sure, but it's not the price setter for our materials.
The customer pays a premium because of the sustainability arguments.
Not just that, it's also the other ingredients and processing of our materials that are relatively expensive, I would say, and also because the properties of the material itself are quite good, so you could use it for a lot of applications, and that's also applications where you just pay more, not necessarily the ones I showed, but.
Thank you.
Thank you very much. Well, it's time to round off, and I would like to ask Maarten to put the last poll, because I'm curious how pessimistic or optimistic you are based on what you heard today.
One second.
No and then I'll keep on talking, because I really would like to round off. I would like to thank all speakers again for their very interesting presentations, and of course, if you have any further questions for them, do not hesitate to contact them. As I mentioned in the beginning, don't forget about our other webinar on the reuse of the liquid of the grass, which is on the 6th of July. And I was told that we would also like you to give feedback on the webinar of today, so there will be posted a link in the chat which you can fill in later, because we are really interested about what you thought about our webinar. And then
almost
waiting for the poll. And otherwise,
and here it is.
No, I was the wrong question, Maarten. But
sorry.
I was having a one, but of course you can also answer this one. I had a question about when do we reuse at least 50% of all grass.
Sorry, I thought you meant the last question.
That's fine, Maarten. But I think considering time, I would like to round it off. So we'll do that. We'll keep that question for another time. So again, thank you all for joining, and I hope to see you next time with our next webinar. So thanks very much.
In the chat, I've just posted the evaluation form that Jaap was just mentioning. If you would all be kindly, so we got too kind to fill this one in, it would really help us for future webinars. Thank you very much.
Okay, thank you, Maarten, for your help. And have a nice day, everyone.